All right, how do we differentiate logarithmic functions? Okay, so I want to show you a quick one on how to differentiate logarithmic functions. Okay, now when we talk about logarithmic functions, we can say, for instance, y is equal to ln of a function. Okay, okay, this I say y is ln of a function. Remember that you have to recall that when I have ln x is the same as log to base e of x. Okay, okay, this log to base e of x. Now this is called the natural logarithm. Okay, now so when I have y equals to ln of a function, how do we find the derivative of the function? It's very easy. Now, how do I get dy over dx? How do I find dy over dx of this function? First step. Now you can see that ln is actually carrying a function here. There's a function inside ln. So what do I do? I'll do 1 divided by the function, okay, then multiplied by the derivative of the function. So the derivative of f of x will now be f prime of x. Okay, so this is just the technique when it comes to solving differentiations of logarithmic functions. Just do 1 over f of x multiplied by what now? Derivative of f of x. So it means that, for instance, I am asked to find dy over dx when y is equal to ln of sine x. Okay, for instance, if I go by this procedure here, then the derivative of the function will be, remember, it's 1 over the function, so it becomes 1 over, the function is sine, so it becomes 1 over sine x multiplied by the derivative of the function. Now the derivative of sine x is cos x, so it becomes 1 over sine x multiplied by cos x. Okay, now we know that this will give us cos times 1 gives us cos x. Okay, now sine comes under. Remember in trigonometry that cos x over sine x is cot x. So the y over dx finally becomes what now? Cot x. Okay. Again, we can have another function. Let's say we have another question like this, for instance. Let's say we have that y is equal to ln of square root of x squared plus x plus 2, something like this, for instance. And we're asked to look for the derivative. Okay, as we're asked to find dy over dx. Let's look for the derivative. We can apply the same technique here in solving. We'll apply the same technique here in solving. Remember, the first step is look for 1 over the function. Okay, now the function that I can see here, is this is what is inside the lane. Okay, so that's the function the lane is carrying. So I'll do, to solve for dy over dx, I'm going to do 1 over the function, okay, x squared plus x plus 2, then remember, multiplied by the derivative of the function. Okay, the derivative of the function. So what becomes the derivative of the function? Remember that what we have here is like saying we have x squared plus x plus 2, okay, to the power of half. Now I can write what I have here like this. How do I differentiate this guy? Remember I taught you a technique then that we bring down the power. The derivative becomes bring down the power. Okay, we bring down the power 1 over 2 multiplied by, find the derivative of what is inside. If I find the derivative of x squared, I have 2x. Okay, so it becomes 2x. Okay, then find the derivative of x, I'll have 1. Find the derivative of 2, I have 0. Okay, so I'll find the derivative of everything here. Then we write everything again. Write what we have again. We have x squared plus x plus 2. Then we're going to remove 1 from the power. So 1 over 2 subtract 1, we have negative 1 over 2. So we have negative 1 over 2. Okay, this is what we have here. Now, the next thing I'm going to do here is to simplify what we have. So from here, we'll have dy over dx, therefore, becomes equal to what we have on top. What do we have on top? Okay, this guy can go down. This, because of this negative, I can bring it down. So on top, we have just 2x plus 1 left. Okay, that's this guy left. Then at the bottom, we are left with 2. Okay, and we're also left with this guy, square root of x squared plus x plus 2, okay, multiplied by, if this guy comes down by indices, this power will change to a positive power. Okay, So we still have the same thing down. Square root of x squared plus x plus 2. Okay, this is what we have. Now remember in indices, remember in solids, let's say solids for instance. Remember if I have square root of x multiplied by square root of x, the result is x. Remember, now it means that square root of this times square root of this, the result becomes what now? This guy, this square root will go out. So do over dx, therefore it becomes equal to 2x plus 1 divided by 2. Multiply this times this, I'm going to be left with x squared plus x plus 2. Okay, and this is the final answer. All right. And let's say we have another question like this that says we should find the derivative. Okay, find the derivative when y is equal to x to the power of 7x. Okay, x to the power of 7x. Now, what can I observe from this question? Okay, if I pay attention very closely, I would see that the base is the same variable as the power. Right? The base is the same variable as the power. So what do I do when I come across questions like this? What we do is take log of both sides. Okay. So what we do when we have questions like this, the first step would be that we take the log of both sides, the natural logarithm of both sides. That will be, if I take log of this guy, that becomes ln y. If I take log of this guy here, that becomes ln x to the power of 7x. Okay. Now there's a rule of law that tells us that the rule of that tells us that if I have log, whenever I have log, okay, log of a number to a power with a base. Remember that the rule tells us that we could write this again as this guy comes backwards. So it becomes n log x base a. Okay. So let's apply the same technique here. Okay. The power comes to the back. So we have ln y is equal to 7x comes back to become 7x dot ln x. We're left with ln x here. Remember, we said ln is log to base e. Remember, now at this point, we can differentiate through. Okay. Now, if we differentiate ln y, what do we have? This is going to be an implicit differentiation because that will be 1 over y. Remember, it's 1 over the function, then derivative of a function. Then derivative of y implicitly would be dy over dx. Now, when you come down here, what you're going to apply is product rule. Okay, this is u, this is v. Remember, I'm going to call this u, I'm going to call this v. So if I apply product rule, what does product rule tell me? It tells me that I'm going to keep this guy, that is u 7x, okay, u dv over dx, which means differentiate ln x. That will give us 1 over x, okay, plus v du over dx. So what's my v? My v is ln x, okay. Du over dx means if I shade 7x, you're going to get 7. All right. Now, x can cancel out x here. We're now left with 1 over y dy over dx is equal to 1 plus 7 ln x. Now, remember, at this point, we have not obtained the value for dy over dx yet. We have to make dy over dx subject of the equation. How do we do that? Now, if I want to make dy over dx subject of the equation, I can multiply both sides by y. So we have y multiplied by this, and we have this side multiplied by what now? By y. If I do this, y can cancel out y here, so that the y over ds here becomes equal to y. Remember y, from our question, y is x raised to the power 7x. So we have x to the power of 7x into 1 plus 7 ln x. Okay? This becomes the solution. All right? Quickly, what if I had a question like this? Okay, let's say I had a question like this. Y is equal to x to the power of sine x. Okay, x to the power of sine x. Like you can see that the base and the base and the power, the base and the exponents are of the same variable x. Okay, now we're applying the same technique here. We're going to apply the same technique here. Our first step will be to take log of both sides. Take log of this guy, ln y. Take log of what we have here. We have ln x to the power of sine x. Okay. The second step would be let the power here comes downwards. So we have ln y is equal to sine x comes back, will become sine x, okay, ln x, okay. The next step will now be to differentiate throughout the equation. Again, if I differentiate ln y, what do I get? Remember how to treat logarithmic functions. It becomes 1 over y, okay, multiplied by derivative of y is what? dy over dx. Okay. Now, when you get to this point, we are going to apply product rules. Okay. We have sine here, we have ln x here. So we're going to apply product rule. Remember product rule. It tells us that we keep this is call this u, call this v, we keep this sine x, okay, then into differentiate v, that will be 1 over x. If we find the derivative of ln x, we get 1 over x plus keep this ln x, okay, differentiate sine, you're going to get cos, so this is cos x. All right, at this point we can multiply throughout by y, okay, to make the y by this subject, or we can simply just take this y over, still the same thing. So I can say the y over dx here becomes equal to y into sine x over x plus cos x into ln x. We close it. Now we replace the value for our y. What is our y? From the original equation, our y is x to the power of sine x, okay? So that gives us the y over dx here. The y over dx here is now equal to x to the power of sine x into sine x over x plus cos x into ln x. Okay, this becomes our answer. So if we apply a logarithmic differentiations in doing this question, we're going to arrive at this answer. All right. All right. Here's another question. Okay, it tells us that we should find the derivative of the function. Okay, we should find the derivative here that tells us find dy over dx. Now we're going to apply the same technique. First step will be take log of both sides. Okay, I take log of y, this gives us ln y. If I take log of this side here, this gives us ln x to the power of x. Now the second step will be the power, this power comes backwards. So it becomes ln y is equal to, if x comes back, it becomes x ln x. Okay. Next step will be to find the derivative of the equation. If I find the derivative of ln y, I'm going to have ln 1 over y dot dy over dx. Okay, then if I want to find the derivative of this value here, I'm going to apply product rule. Okay, so if I apply product rule here, I'm going to keep x, differentiate ln x, I want to have 1 over x, okay, plus, we're keeping ln x this time, ln x. If I differentiate x, I'm going to get 1, okay. So what I have here, I have that dy over dx, therefore, okay, y dot dy over dx would be equal to, if I multiply both sides here, this will cancel out this. So I have 1 plus ln x. Now to make the y over dx subject, you can easily multiply, you can easily, okay, from here, we have 1 over y, rather. Okay, so to make the y over dx subject, you can easily multiply throughout the equation by y. So we have y times this, we have y times this, okay. Y can cancel out y. So we have that dy over dx, dy over dx is equal to, what is y from original equation? X to the power of x. So it becomes x to the power of x into 1 plus ln x. Okay. So remember this is our y. Okay. So if I can still place y here or place y here, so I could place x to the power of x here or here, it still gives me the same answer. Now, so it means that if you find the derivative of y, if you differentiate this guy, your answer should be x to the power of x into ln x. Okay. Now, quickly, if you know the value for the derivative here, you could easily do this. We could find the derivative of y equals x to the power of x to the power of x. Okay. Now, what I have here, look at what I have here. I'm having x raised to the power of x and also raised to the power of x. Okay. Of y equals x to the power of x to the power of x. Okay. And how do we solve this question? Now, to solve this question, we apply the same technique here. Okay, we take log of both sides. So let's take log of both sides now. This becomes log y becomes ln, okay, ln y equals ln x to the power of x to the power of x. Okay. Now what you do here is take this guy, let this guy, take these guys to be, we take them, okay, together. So by our rule of logarithms, it comes to the back. So everything here is coming backwards. So we have ln y becomes x to the power of x dot ln x. At this point, we take the derivative of the equation. Derivative of ln y gives us 1 over y dot the y over the x. Okay. Then the derivative of what we have here, we apply product rule. Okay. This gives us u. This gives us v. Okay. Now, what is product rule? It gives us u dv over dx plus v du over dx. So u is x to the power of x. Dv over dx means differentiate ln x. That will give you 1 over x plus keep v. We keep v. That will be ln x. Differentiate x to the power of x. We've done that already. This is the value x to the power of x into 1 plus ln x. So this gives me, we find the derivative of x to the power of x, we have x to the power of x into 1 plus ln x. Okay. Now, at this point, the next thing I'm going to do is to make y by the x subject. How do we do this? So this y comes over, or we can multiply both sides by y, so that y cancels out from here. Now, if I multiply both sides by y, I multiply it by y, and I'm also going to multiply everything here by y. Okay, so that my y can cancel out y. What becomes my dy over dx? Dy over dx therefore is, now we have this, we have x to the power of x over x, okay, plus we have here x to the power of x ln x into 1 plus ln x, okay. Then we have everything inside a bracket multiplied by, remember our y, this is our y, okay. So y is x to the power of x to the power of x, okay. At this point, we can now do a little factorization here. This is, remember, this is multiplication. This is multiplication or multiplying. So the y over dx therefore becomes x to the power of x to the power of x multiplied by x to the power of x is common on both sides here. Okay, so I can bring it out to have x to the power of x. Now we'll open brackets 1 over x again plus ln x into 1 plus ln x. Okay, we'll close it. Okay, so this is the answer to the derivative here. If you find the derivative of y equals sine x all to the power of sine x. Okay, now we're still using the same technique. We take log of both sides. We take ln y is equal to, take ln of this side. So we have ln sine x all to the power of sine x. And from our rule of logarithms, this sine x can come backwards. It's a rule of log. Okay. Remember that if I have from the log, if I have that log x to the power of n base a, the n can go back. So we have n log x to the power of a to the base of a. Okay. Now you can do the same thing here. N comes down. Okay. N comes down. Log x to base a. All right. So do the same thing here. We have ln y is equal to sine x comes backwards. Sine x. Okay. Then ln sine x. At this point, the next step is to take the derivative of the equation. So the derivative of ln y gives us 1 over y dot dy over dx. Derivative of what we have here, we apply product rules, okay? So I apply product rule here, we keep this. If we keep sine, this is sine x. Then, if I differentiate ln sine x, remember, it's 1 over sine x dot, find the derivative of sine x, that will be cos x, okay? Now, this is u dv over dx. Now, we have to add it to v du over dx, okay? Du over dx, differentiate sine, you get cos. All right? Now from this point here, sine can cancel out sine easily. So we have 1 over y dot dy over dx is equal to cos x plus cos x ln sine x. Okay. Now to remove this to remove this y from here from the left hand side, I can multiply both the right hand side and left hand side of the equation by y, so that this y can cancel out this y here. So we have that dy over dx is equal to, now this y can come forward, you can still leave it that way, no problem. Okay. Now if I factorize cos x from here, this is cos x, it comes out, what will be left here is 1, what will be left here is ln sine x. Okay. Then remember that y originally is sine x to the power of sine x. Okay. Now this is the derivative of sine x to the power of sine x. Okay. This is derivative.